Question 29. Let x denote a normal random variable with mean 0 and standard deviation 1. The random variable x has the probability density function f of x equals 1 over the square root of 2 pi times e to the power of negative x squared over 2, where x is greater than negative infinity and less than infinity. The diagram shows the graph of y equals f of x. Part A. Complete the table of values for the function given. Give your answer correct to 4 significant figures. The value missing in the table corresponds to f of 2. To find the value of f of 2, substitute x equals 2 into the function. So f of 2 is equal to 1 over the square root of 2 pi times e to the power of negative 2 squared over 2, which equals 0.05399909 and so on, which rounds to 0.0540, correct to 4 significant figures. Part B. Using the trapezoidal rule with the 4 function values in the table in Part A, show that the probability that x is greater than or equal to negative 3 and less than or equal to 3 is equal to the integral from x equals negative 3 to x equals 3 of f of x dx, which is approximately equal to 0.9953. The trapezoidal rule with 4 function values implies 3 applications of the trapezoidal rule. In other words, we're going to estimate the area under the curve from x equals 0 to x equals 3 using 3 equally spaced trapeziums. And we can see here that the height of each trapezium is 1 unit, so h equals 1. So the area of one trapezium is equal to half times the height times a plus b, and this is the formula for the area of a trapezium, where h equals 1. And the probability that x is greater than or equal to 0 and less than or equal to 3 is approximately equal to half times 0.3989 plus 0.2420. So that's the first application of the trapezoidal rule, plus half times 0.2420 plus 0.0540. That's the second application of the trapezoidal rule, plus half times 0.0540 plus 0.004432, which is the third and final application of the trapezoidal rule, and that equals 0.497666. Now we're dealing with an even function, so to get the probability that x is greater than or equal to negative 3 and less than or equal to 3, we just double this result. So that's equal to 2 times 0.497666, which is equal to 0.995332, which is approximately equal to 0.9953 as required. Part C. The IQ, intelligence quotient, scores for a large population are normally distributed with a mean of 100 and a standard deviation of 15. Using the result obtained in Part B, calculate the probability of randomly selecting a person with an IQ score above 145 from this large population. The first step is to calculate the z-score that corresponds to an IQ of 145. Applying the z-score formula, z is equal to 145 minus 100 in brackets divided by 15, which equals 3. The 145 represents the IQ of interest. The 100 represents the mean of the population, and the 15 represents the standard deviation of the population. Now, the probability that z is greater than 3, or in other words, the IQ is greater than 145, is equal to 0.5 minus the probability that z is greater than or equal to 0 and less than or equal to 3. Referring to the graph of the normal distribution, the probability that z is greater than 3 is represented by the area in this part of the graph here, so under the curve here. So in order to find this area, we take 0.5, which represents the area under half the normal curve, and we subtract from that the area from z equals 0 to z equals 3. So that equals 0.5 minus 0.9953 divided by 2, which equals 0.00235, which equals 0.235%. So therefore, the probability that a person with an IQ of greater than 145 is chosen is equal to 0.235%.